Hello, students. Welcome back to your computer science class. This is grade 12, and I am Mrs. Jenny Shah. We've completed three parts of chapter 1. So while I'm enjoying a cup of coffee, I hope you all are too. I really love that cup of coffee on that table. When I see it, it really refreshes me. I hope it refreshes you too. So we are doing chapter 1, Python revision tour. And now today we are going to be talking about list. Now list is the most versatile data type available in Python, which can be written as a list of comma separated values. And this is enclosed in box brackets. Good thing about list is that items in a list need not all be of the same type. Now, creating a list is as simple as putting different comma separated values between square brackets. There are three lists on the screen. List 1 is a mixture of strings and integers. List 2 is only integers. And list 3 is only strings. So, simply said, list is a data type in which we can store different data values in an ordered sequence. It is mutable and it is denoted by box brackets. Like string indices, list indices also start as 0. A list can also be sliced, concatenated, as well as replicated. Okay, so a Python list, this is the structure of a Python list. The name of this list is color list. There are 5 words in it, 5 strings: red, blue, green, black, and blue again. Like you can see, you can repeat values in a list. Each and every these are called list elements. Okay, and there is forward indexing as well as backward indexing. Now, forward indexing starts with 0. Backward indexing starts at -1. That is simply because if it also started at -1, then if it also started at 0, then the index 0 would actually be pointing at two different data types, which would create a load of conflict. So forward indexing starts at 0. Backward indexing starts at -1. List indexing is the same as string indexing, but a list is mutable. That means if I write something like, suppose I write something like color list in place of 4 equals to, let's say, white. The change will happen. You will be able to see white over here, and the memory address of the list will not change. That makes the list mutable. That means you can make a change in the same list. Moving on. I have to say I have a few notes where I had written down things I really wanted to teach you. Next was traversing a list. You can traverse a list just like we traverse a string, but I have a special explanation for you all. Okay, I'm just going to take the whiteboard for that because definitely don't want my things to disappear like last time. Let's say I have a list of lists, so something like a nested list. Um, okay, let's say this is my list. Now, if you look at list, let's look at the list element. This is my element 1, element 2. This is my element 3. This is my element 4. And this is my element 6. Okay, so let me just number it so that we start with 0 with indexing 0, 1, 2, 3, 4. If I look at backward indexing in this list, it's going to be -1, -2, -3, -4, and -5. All right. Now, in this, if you look at these two things, these are, inside it. So in this second or -3 element of this list, I can further have sublist. I can have sub-index. So again, this is going to be 0, 1, 2, 3, 4. No, this is not going to be 3, 4. This will again be 3 only. Because like you can see, these two over here are string and list again. So these will be, again, there will be one more index layer over there. 0, 1, 2, 3. Again, there will be backward indexing. I'm not writing it over here. This will be 0 and 1. And over here, this is going to be 2 and 3. This is going to be 1 and 0, like I have written on the top. Okay. So now, let's say I want to print out the number 14 over here. Okay, in that case, I will say print, open bracket, A, which is the name of my list, and in box bracket, we must specify the index value. Now, the index value of 14, suppose if I write 2 over here, my output is going to be something like the entire list. I'm going to get 14, comma 1, comma today, comma 4, comma 5. I'm going to get the entire list as my output, but I wanted only the number 14 to be displayed. In that case, I should have written print A part 2 part 0. Now when I do this, my output is 14. Okay. Now, let's say I wanted to put the output as today, the entire word today. In that case, I need to write print A. I can even use the negative indexing. So I can say -3 And in minus 3, I can again use negative indexing and say minus 2. So this will give me the word today. Another one I can say is print A. And in A, I'm going to say, let's say, now I want you all to guess this. Okay, so I'm going to say minus 3, 2, then I'm going to say, can you guess what will be the output of this? The output of this will be C, because I said minus 3. So I'm going to go to minus 3. That is here in this element, in this box. I said 2. So 0, 1, 2. So we went to today. And then I said 2 onwards. So 0, 1, 2 onwards till the end. So T, A, Y, and so on will be end. Okay. One more example. I will just show you all the dictionary one. So print A in the part for. When I do this, I'm going to get the output as 1 ratio round. But suppose I want, let's say I want only the part, I just want the part, let's say, of the dictionary. I just want it to be displaying, like RAM, for example, let's say. Okay. In that case, I will say print A in the place of 4 and the value of key. Remember, the number 1 over here depicts the key. So then I get the output as RAM. Remember, this over here is the key. This over here is the key over here. So if my key would be 2, then I would be writing 2 over here. If my key would be something else, I'd be writing something else over there. This is the key of the dictionary. All right? Is this clear? Okay, let's clear all the drawings and go back. So that was the structure of a Python list. There are many there are many functions in list that you can use in according to your need and along with traversing it. For traversing it, you simply write for x in A and then print x or whatever you need to do. Functions are length for length, append is to add, insert is to insert something, pop is to remove an element. Remove is also to remove an element. The difference is pop will give a return value, remove doesn't. Minimum, maximum, count, sort, index, clear, etc. So this was all about this. Now, for grade 12, you should know how to create a list, how to access a list, slicing of a list, which is same as slicing of a string, reassigning lists because they are mutable, so you can update it. You can delete elements. There are multi-dimensional lists because there can be a list inside a list inside a list. Concatenation of lists, operation on lists, iterating a list, list comprehension, built-in functions of lists, built-in methods of lists. This is the basic of lists that you should know that we have already completed in grade 11. Tuple. The next topic is tuple. Now, what is a tuple? You can say it is a data type which is used to store different data values in an ordered sequence. Most important is it is immutable and it is denoted by round brackets, round parentheses. You see, tuples are exactly like lists. They do the same functionality, except you cannot change the value once defined in a tuple. Once you make it into a tuple, the only way to modify it is putting it back into a list and making the changes and bringing it back into a tuple. On the screen, we have a couple of examples of a tuple. You can see an empty tuple. You can see a tuple of numbers. A tuple of mixed numbers because you can see a complex number right there. A tuple of mixed data types, which is a number, a string, and a list. You see a couple of tuples also. So these are the things you must know in a tuple. Since tuples are immutable, you must remember that you cannot change it. So suppose let's say this is my tuple, let's say. Sorry for that. Let's say A equals to one of this, okay, for example. I cannot write something like A in place of 1 equals to 22. This is not allowed. It would throw me an error. It will tell me tuples are immutable. Okay. Another thing that we must pay a lot of attention with a tuple is the fact that it can get confusing. So for example, I have a tuple A and I say equals to, I'm making it a tuple over here, okay? I'm saying in the box bracket 4. So this is going to give me an error because, not give me an error, but when I'm going to check the type for this, it's going to tell me it is an integer. And that is because 4 in round brackets is nothing but normal 4 and 4 is an integer. How do I change that? So to change that, what I really need to do is I write A equals to open brackets 4 comma. Now when I put a comma here, it understands that this is a tuple. Okay. So another thing to remember is this. You need to put a comma to make it a tuple. Alternatively, you can also make a function. So I can say A equals to, and I write tuple. I use the inbuilt method. This is absolutely correct to make an empty tuple. Now, you can traverse a tuple just like you traverse a string or a list. It's absolutely the same. Slicing is something which is again another same thing. So you know how string slices work, which I had done a good detailed video on last year. Okay, in case you missed it, open your textbooks of last year, go through it, understand it. Slicing works in the same manner. Then there is concatenation. Okay, there is indexing, forward indexing, backward indexing. There is a repetition. Everything is absolutely the same. Another thing that we need to learn over here is definitely packing and unpacking. Now, what do you mean by packing and unpacking over here? Now, let's take this tuple only, 33, 55, and 77. Let's say I said A equals to this. All right. Now I can say something like X, comma, Y, comma, Z equals to E. Now you will tell me, man, when you taught us variables, you said if I cannot do multiple assignment like this, unless I have equal number of values on the other side. Because I remember saying if you have X, comma, Y, comma, Z, you need to have 3 values over here, whichever may be the values, but there need to be 3 values. Only then this is correct, and this was wrong. And today I'm going back on that statement. Well, This is a special feature, and this is called unpacking. This is called unpacking of a tuple. Okay. Okay, so I can say x comma y comma z equals to a, and my 43 will go to x, my 55 will go to y, 77 will go to z. But again, there is one rule. The number inside, the number of elements in the tuple should be equal to the number of variables I'm trying to unpack it with. Okay, so this is called unpacking. Similarly, we can also do packing. That means I can also say y equals to 8. That is also correct. So I can say x comma y comma z equals to a, and that will become packing. And when I say x comma y comma z equals to a, it becomes unpacking. What's the catch, miss? You said the same thing 2 times. I'll tell you. In the first one, when I'm using this as, let's say, when I'm using this as packing, okay, not unpacking. I'm using this as packing. In that case, A is not defined, is not declared. There is no variable as A as such. There are only values in X, Y, and Z. Okay, I have already initialized values before this, which says X equals to 3, Y equals to 5, Z equals to 1. And then I said X comma Y comma Z equals to A, and this becomes packing of a tuple. Now, let's look at the reverse scenario where I have declared A. In this kind of a scenario, when I say X comma Y comma Z equals to A, then the values are being put and not put. This is happening, and so this is called as unpacking. Okay, so this was packing and unpacking of a tuple. Moving ahead, these are the tuple functions: length, maximum, minimum, sum, any, all, sorted, tuple. So you can use any of these functions. You should know the variations of these functions. You should know how to create a tuple, how to access or how to traverse a tuple, slicing of a tuple, deleting a tuple, reassigning a tuple, functions on a tuple, methods on tuples, operations on tuples, iterating a tuple, and nested tuples. These are the things we covered last year. In case you have any difficulty in any of this, you must go back to your textbooks, learn it, look at the examples, learn it, and still if you can't figure it out, get in touch with me. Now, we did tuples, we did lists. So what is the difference between the two? Now, Python lists are surrounded by square brackets, and Python tuples are surrounded by parentheses. If you look at the mutability, lists are mutable in nature. That means you can change the value in its own memory location. But tuples are immutable in nature, and you cannot change the values in the same memory location. Methods. There are 46 available methods for lists, and there are only 33 available methods on tuple. Usability. In a dictionary, we cannot use list as the key of the dictionary, but you can use the list as the value of the dictionary. And for tuple, in a dictionary, you can create a key using the tuples in a dictionary. So this is another basic difference between the two. Next is dictionary. Now, okay, this is an error here. So dictionary is a data type which is used to store different data values in a key value format. It is mutable and it is denoted by round brackets. Can you see the round brackets on our screen? It is denoted by round brackets. Not round brackets, curly brackets. All right. It is denoted by curly brackets. So over here, like you can see, there are key value pairs. I'm going to just highlight with different colors for you to understand. The purple ones are key. The green ones are the value. And let's see the pink one over here. These are the separators, the key value pair. There's one more separator right here. This is the separator of the item. So in this dictionary, there are two items. This is one key value pair and this is another key value pair. All right. So you can say this dictionary has two elements or two items. Now, very important, the key. Key has to be something, anything that is immutable. I'm just going to write IM over there to know. The value can be immutable or mutable. I repeat, a key must be immutable. That means it must be a float, a string, an integer, or a tuple. I repeat, a key must be a float, a string, an integer, or a tuple. But the value can be any data type. Another thing to remember is a key must be unique. That means in the entire dictionary, the key cannot be repeated. This one can't be one, the next one can't be one. One is taken, one is the key. It has to be unique, it has to be different. But the value, it can be repeated. That means I can have another one that says, I'm sorry for my handwriting. Okay, I can have another one after this which says 3 colon, and again it says apple. That is allowed. But a key cannot be repeated. A key must be unique. So that is all about the dictionaries. Remember, two keys cannot be the same in a single dictionary, but two values can be the same in a single dictionary. Now, dictionary methods. So in the dictionary methods, we have clear, which deletes all the values of the dictionary and makes it an empty dictionary, but the dictionary still exists. Then if you look at pop deletes the key value pair completely and get will return the value of the key. Items will create a list of tuples in a key value format. Values will create a list of values. A key will create a list of keys. Length will give us the total number of keys or key value pair in our dictionary. Delete will delete a particular key. If you mention the name, if you mention the key in the bracket, will delete that key. And if you write the name of the dictionary in the bracket, it will delete the entire dictionary. There are also nested dictionaries. One dictionary can have another dictionary in it. We also have sorted and update functions in the dictionary. Dictionary is a very important concept and it must be clear before you go ahead and learn. The next part of Standard 12 Computer Science. With this, we've come to the end. Let's do a few questions that you all will be solving for the next class. Okay, so these were the questions I told you all to do last time. Let's fill in the answers. What built-in function do you use to convert a string into a float point number? Demonstrate this function by converting string 85 into a floating point number and assigning it to a variable x. So let's look at the question in two parts. What built-in function do we use to convert a string? We use the function float. Now demonstrate it by using, so I will say a equals to 85 in a string format over here. Then I will say x equals to float. The bracket. Okay. What building function do you use to convert a string into an integer? We use int. What happens when you try to convert a string into an integer, but the string is not a number? It will throw us a type error. All right. What would be the output of this code? I told you all to self-check this and this also. I'm not going to give you all the answer. Moving ahead, this also you need to do on your own. Moving ahead, in each of this is the next set of questions you're going to do. In each of the following Python expressions or statements, indicate what data type belongs in the indicated place by choosing one of the following data types. So you just have to write what will come. So s equals to dash plus 17. So what should come over here? What options can we put? We can put an integer, and we can also put a string. C equals to dash plus pi. So again, we can put a integer or a string. X in the bracket of dash equals to cat food. Now what can come over here? A list. Is it? Yes. So X in the place of 1 or 2. So this will be integer, sorry. So this has to be integer. Dash dot sort, this has to be a list. If dash, so if, bool, so true or false has to come over here. So if true or if false, you're going to do this. So over here, it will be integer or string. This will also be integer or string because this is concatenation. And with concatenation, you can use an string or an integer. That's fine. Or, no, you can't. Sorry, that is multiplication. So over here, this has to be a string. This has to be integer or float. Yeah, float will work over here. This has to be integer again. This has to be a list, and this has to be Boolean. Okay, fine. We got this. Okay. Next one. What does Python print as it executes the following sequence of statements? So you're going to put what does Python print? You're going to put the data type over here. What data type will it print? So, 10 plus 3 into 2, whatever it will be an integer. 11 divided by 2 will be a float because it's going to not give me a complete value. It's going to give me a float value. X into 25 equals to 50. So because I have used equals to, it's going to be Boolean type data type because it's only going to tell me if it's matching or it's not matching one of the two. So this is going to be bool. This is going to be float. It's going to be integer. X more than or equal to 50. So again, this is just going to be bool. Print a plus b, so it's going to give me a string because my both a and b are strings. C equals to length of a plus length of b, so it's going to give me an integer. Print a, over here, I'm assuming a is this, so it's going to give me string. And this is also going to give me a string. It's going to give me a character. You can go a little detail and say character because it's a single character, or you can say string itself. That's absolutely fine. So this is the answers to this question. Moving next, going ahead, what would the output of the following code be? Now, this is something you're going to do, and you're going to first write the answer down, and then you're going to be checking it with your Python IDLE. Again, output question, you're going to support your answer with reason. So when you write the answer, when you write the output, you're going to write whatever is your thought process. You're thinking that I think the answer is going to be so and so because according to me, this will happen, this will happen, this will happen, and so the final output would be this. All right, and then you're going to be checking with the Python interpreter. With which of the following statements would yield to? Means we'll give you the answer to. Assuming that the math module is imported, recall that math.fabs gives you absolute values for its arguments. Wherever fabs is there, it's going to give you absolute answer. So you're going to do all these also. So from question 3, 4, 5, even 6 and 7. I repeat, 6 and 7 and 8 and 9. So from question number 3 over here, 3, I'm going to pause for 2 seconds on every screen. So you can click a picture or solve it in your notebook. That's absolutely fine. Pause the screen. 4, 5. 6, 7. This is linking to the previous question. So you will need the previous question when you're solving this. Question number 8, you're going to say the output of these statements. Look very carefully with all the parentheses that are being used. How are they being used? Some of these could give you an error, so you must be very careful. 2 parentheses open, 3 parentheses closed gives an error. And the last question is, what will be the output of the following? Tricky question, simple answer. Put the values there and see. Print true or false and false. Think what do we do first, or and then how? Use operator precedence for this. All right. So with these children, I am ending today's class. I think this is another question you should do because it's Boolean based and it comes in this. To do this question number 10 also. I'm sorry, I'm not ending this class still. This we'll do from next time. Okay. So question number 10, you're going to do it in your practical books. If you don't have practical books, doing it in your notebooks. With this, children, I end today's class. Stay home, stay safe, take care, keep learning.